Mosquitto is an open source broker for the MQTT protocol. It is maintained by the Eclipse Foundation, and it is lightweight, which makes it relatively straightforward to install on a variety of systems. Note that it is just a broker, so it lacks a backend database or front-end dashboards that you might find in fully featured IoT platforms, but it is a good starting point if you want to build a fully managed, self-hosted IoT platform. You'd have to connect a database to the broker in order to store the data from your devices. If you head to mosquitto.org, you can find information on how to download and install the broker on different operating systems. Linux is quite stable and offers good security features, which is why I like to use it for server applications like this. In the rest of the video, I'll show you how to install Mosquitto on a Debian-based system, configure it with a self-signed certificate for TLS communication, and test it using an MQTT client. Before we start, I want to let you know about my ESP32 IoT course. If you're enjoying this content, I highly recommend checking it out. We start with the basics of ESP-IDF for writing professional code for the ESP32, then learn how to read from connected sensors and transmit that data over Wi-Fi using HTTP REST API calls to an IoT platform. We'll also tackle publish-subscribe mechanisms with MQTT before seeing how to secure everything using Transport Layer Security, or TLS. By the end of the course, you'll have the chance to build a full IoT sensor that publishes data to an MQTT broker, and you'll earn a digital certificate to showcase your new skills. Click on the link in the description to sign up. In a terminal on your computer, assuming you have Docker Desktop installed, let's pull a recent version of Debian. I'm going to be using stable 2024-1223, and this is the slim version, so it doesn't come with a whole lot. Note you can do this if your host is something like Ubuntu or, say, on a Raspberry Pi if you want to create a home server. I'm just using Docker, so you can see how to install this on a Debian distribution in a temporary fashion. But feel free to take these steps and turn it into a more permanent server if you would like. Next, we are going to Docker run. We will use --rm to remove this container when we are finished, so nothing will be saved. Keep that in mind if you actually want to turn this into a more permanent server. -IT for interactive mode. We will expose the ports for 1883 for non-secure MQTT communication and 8883 for secure MQTT communication. We will use that Debian image we just pulled, and we will start in bin bash. This will give us a bash prompt so that we can start working inside of the Debian container. Now that we're inside of that container, let's go ahead and install some dependencies. First, we will call apt-get update in order to update our repositories. Then we will apt-get install -y to avoid having to press Y later. Nano, which allows us to do some very basic editing. You're welcome to replace this with any editor you'd like. And proc ps, which allows us to do the ps command to see what's running in the background. Then we will call apt-get install -y Mosquitto, which is our MQTT broker, and the Mosquitto clients, which allow us to do things like testing, publish, and subscribe to that broker. Give it a moment to install everything. Once that's done, you can run Mosquitto as it is in default mode, but we should take some steps to secure it, and I'm going to walk you through all of those. The first is setting up a basic username and password for Mosquitto so that your clients need to have some sort of authentication, and give it the location of where to store our hashed password file. In this case, we will point to etsy/mosquitto/password, and then we'll give it the username. In this case, we're just going to set up a very basic username of IoT, and it's going to ask you for a password. I'm going to set the password to Mosquitto with 2 T's, just like the name of the tool we're using, but you are welcome to use whatever username and password you see fit here. It will ask you to re-enter the password. Do that, and you will be done. We can view that password file if we just cat it. You can see the hashed password there. It will be given as username, and then the password hash. So this is a secure way to store the password. So even if somebody can read it, all they have is a hash, and it would take some time with like a rainbow table attack to figure out what password actually equals that hash. On some systems, like our bare bones Debian installation here, Mosquitto does not have access to be able to create, write, and read its own PID file, which it needs to interact with the operating system. So we need to give it a little help here. To do that, we're going to call makedir/p for creating recursive folders and /run/mosquito to set up a Mosquitto folder in the run directory. Then we will change the ownership of that directory to the Mosquitto user and Mosquitto group so that the Mosquitto tool actually has access to it. And then for security reasons, it's generally a good idea to set the permissions for that folder, as we will do for some other folders later, so that the Mosquitto user and group can execute read-write from that folder and then lock out other users. In this case, we're going to say group users and others have read and execute permissions only from that folder. That way other processes can't write to the PID file. Because we've set up a username and password, we need to do some basic configuration in Mosquitto. So use your editor to go into etc mosquitto.conf. Inside there, you will find a very basic, bare bones configuration file. I'll add a few comments here so you can see what's going on with each of these lines. Here is the location of that PID file where we constructed that directory where it will be stored. PID files are usually used by daemons or services, which this will be, and it stores the actual process ID of that running process. Other servers or administrators can check if the PID file exists. You can read its contents to find out more about that actual process. But for our purposes, we needed to create that folder and give the Mosquitto user permissions to read and write that PID file. Persistence true means that the Mosquitto broker can store information about the state of the broker. That means things like retaining client subscriptions and any undelivered messages that are, say, marked with quality of service 1 or 2 to some sort of backend file here, so that when the server comes back online, it can deliver those messages to the subscribed clients. We will also provide a location of where to store this. This is in var lib mosquitto. Normally, Mosquitto runs in the background as a daemon, which means that it won't necessarily print anything to the console. So any debugging information should be stored somewhere. In this case, we set up a log file located at var log mosquitto.log. If you need help debugging because Mosquitto is not doing what you think it is, just print out that log and take a look at the last few lines to figure out what's going on. Mosquitto by default will also want to know where to store extra configuration files as it runs as a background process. In this case, we will point it to etc mosquitto conf.d. Mosquitto will know what to do with that directory, assuming we have set that include dir variable. By default, Mosquitto allows for anonymous connections, which means anyone can connect to the broker to subscribe and publish data. To set up that username and password file that we created, we first want to specify allow anonymous to false, which means that no one but the people specified in that password file can connect, and they won't connect without the right password. And then we specify the location of the password file. In this case, we set it to etc mosquitto and password, or that's passwd. This is the file that we generated earlier, and it contains a list of usernames along with the hashed passwords. That's the only thing we needed to add to this configuration. So let's save it, Control X and Y, enter to save that location. Then we will actually run Mosquitto in the background as a daemon. We will call Mosquitto-C to give the location of our configuration file, which is etc mosquitto.conf, and then -d to run it as a daemon, which means run it in the background. It won't print anything to the console, but if you run into problems, you can cat or tail var log mosquitto.log to see what's going on in that Mosquitto server. Next, we will use a couple of Mosquitto client tools in order to subscribe to a topic and publish some messages. The first is, let's try this Mosquitto pub. We will specify -h for the host location, in this case, localhost. This could be the IP address of wherever you're running your server, or say www.mymqttserverbackend.com, whatever the host location is, -p for the port. In this case, Mosquitto by default opens up port 1883. As you can see by the end of that log we printed out earlier, that it's listening on 1883 for IPv4 and IPv6 connections. -t is the topic. In this case, let's try kitchen/sensor. -m is the message. We will transmit this very simple JSON string temp and 25. -u is the username. That's IoT. -p, capital P, is Mosquitto, and that should line up with the password we created earlier. Let's try this, and you see nothing gets printed out. Let's try printing out the tail of that log again. And sure enough, you see that we do have a new client that connected to us, but it doesn't give us much information about the message that was sent. It just shows that the client connected and then disconnected. To see these messages, we need to subscribe to that topic. Here, we're going to use another Mosquitto client tool called Mosquitto Sub for subscribe. -H is the host location, in this case, localhost. -P is the port, 1883. -T is our topic. We could subscribe to kitchen/sensor, but let's try a wildcard here. We're going to use kitchen/plus, which means any single subtopic within kitchen, the username IoT, and the password of Mosquitto. I'll put an ampersand at the end, which means to run this tool in the background. You will see it's been given a process ID number here. And then let's try publishing that message again. I'm just going to press the up arrow key to go to the previous message. This is the exact same message we sent out earlier. Press enter, and sure enough, now the subscribe tool actually prints to our console that message we received from the publish message. In this case, it's that JSON string of temp25. Keep in mind that these Mosquitto client tools are really for testing your broker. For most IoT applications, you will be developing clients, and that means using things like C or C++ libraries for MQTT, or like, say, run an IoT application on a Raspberry Pi. I have not found a clean way to shut down these processes, so all I'm going to do is ps-ax to print out the processes, pipe that to grep to look for the string Mosquitto. You can see here that we have the Mosquitto server running, and we have Mosquitto subscribe running. Since I am root, I'm just going to call kill 441 to kill the Mosquitto server, and I will call kill 445 to kill the Mosquitto subscribe tool. Now, if we search for those processes again, we see that they are no longer running. In the next section, I'll walk you through the process of setting up a digital X509 certificate so you can use TLS to securely communicate with your server. Note that we are going to self-sign the certificate. This is for testing only. Once you're happy with how things are working, you should replace your self-signed certificate with one signed by a real trusted certificate authority, like Let's Encrypt. Let's Encrypt is a popular trusted certificate authority run by the nonprofit Internet Security Research Group. They are set up to provide free digital certificates to help improve the security of the internet at large. It uses an API based on the ACME protocol, which lets you automate certificate generation for your site. Because their certificates expire every 90 days, you'd likely want to set up this automation. Also, they verify your ownership over a domain before issuing you a certificate, so it can be a little tricky if you're working with a server on your local network. Back in our terminal, if you don't already have it installed, let's install OpenSSL. We will do that with apt-get install-y OpenSSL. Then we will navigate into etc. Mosquitto CA certificates. This is where we will store our certificate authority certificates that we're about to generate. The first thing we need to do is generate a certificate authority key. This is a secret key, which means it's private and should not be shared. To do that, call OpenSSL gen RSA-out, give it the name of the file, CA key, and how many bits we want that key to be, in this case 4096. That will take a moment and generate a key. If you call ls, sure enough, there's our key. And just for demonstration purposes, you can print out that key, and it is a private key, as you can see here. Then we will use that key to generate a certificate authority certificate. To do that, we will call OpenSSL rec for request. We want a new certificate. We want it to be an X509 certificate. We want a new certificate, in this case -new means create a certificate request, and then by specifying X509 as a parameter here, we say go ahead and generate the full certificate rather than a certificate request. We then specify how long this certificate is valid for, or when does it expire. In this case, we will set it to 100 years from now, 36,500 days. Normally, you would not want to set a certificate to expire this far in the future because of potential security concerns, but this is for demonstration purposes. In general, you'll find that root CA certificates like this one expire every 10 to 20 years because we can assume browsers will update their trust stores by then. And you will find that certificates signed and issued by a CA expire on the order of once every about year. We then give it the key. In this case, the location of the key is the ca.key file we just created. We want to specify the out file, in this case ca.cert, which is the certificate authority certificate, and we will give it this subject line. Here we give it the location of the certificate authority, in this case the country where the organization or server is located. For me, that's the US, the state, that's Colorado, and the locality name or city. This is Denver for me. Feel free to make this whatever you want. Then we give it the organization name. This might be Let's Encrypt or some other company that's running a certificate authority server. But let's just give this some random name, custom CA. And then we need to give it the common name or CN. This is often the domain name of the certificate authority, but we'll just call it custom CA again and match our made-up organization. Sure enough, you can see our ca.key that's been created here. We can print that out and it's another key. By default, OpenSSL does provide good permission recommendations for those cert and key files. In practice, nobody but your CA server should be able to mess with either of those files. Nobody should have read access to the ca.key other than, say, root of the CA server, because that is a private key. And then the certificate should be able to be read by anybody else because that is publicly served. And we are going to use that to check our trust chain whenever we try to securely connect to our broker. So we do need access to that ca.cert, which it looks like we do have read access for everyone outside of root here. Let's go back into Mosquitto. And then in that Mosquitto installation directory, you will see that there is CA certificates for the certificate authority. And then there's another one called certs. These are the server certificates that we will generate and use our made-up CA to sign them. We will first generate a server key. Once again, that's to be private. And then we will generate a certificate signing request or CSR. We will use that and get our made-up CA to generate a server certificate for us. And that's how we can check the chain of trust by giving other people, other clients, that ca.cert. Let's go into certs. We will then call OpenSSL gen RSA-out server.key and give it the number of bits, 4096. This generates a server private key for us that our Mosquitto server should only have access to. Note that the CA, the certificate authority, and the server, Mosquitto server, can be two separate things. And usually that's how it's done. We're just pretending to be both the CA and the server in this case because we are self-signing our certificates. Then we will generate a certificate signing request. Here we call OpenSSL rec for request, much like we did earlier for the certificate authority certificate, but we're not giving it X509 because we're not automatically generating a certificate yet. We're creating a request that we will send to our certificate authority, and we will tell it where to save this certificate signing request or .csr file. And once again, we need to specify this subject line. In this case, the country is US, state is Colorado for me, locality is Denver. Organization is something made up. I'm going to call it My Mosquitto. This could be the name of your company, for example, or your home location if you were running a home server. And then we will give it the common name. This common name is incredibly important. This needs to match the host that we are trying to connect to because clients will check to make sure that the host it's connecting to matches the common name listed in the certificate. The host can be something like localhost if we are connecting to ourselves on the same computer. It can be the IP address of wherever your server is, or it could be a host name like mycustomMQTTserver.com if you say bought that domain. But clients, as part of the security check, will absolutely check to make sure that the host they are connecting to matches the common name in the certificate. If these do not line up, your connection will likely fail. Most modern computers support multicast DNS or MDNS. This is given as your host name on your computer .local. So you could set this to your MDNS name, which would be hostname.local. That will help other computers on your network, your local network, find it. While I won't show it here, you do have the option of setting up aliases. You can define what's known as subject alternative names or SANs in a list with these alternative names, and the client will check against these as well. So you could set up localhost and your IP address so that you can connect both locally on your machine with localhost, or outside clients can connect to that IP address, and you can still ensure a successful, secure connection because the common name lines up with what you're trying to connect to as part of your host. Let's press enter, and we should have our .csr file now. Now we are going to pretend to be the certificate authority. In that, we are going to call this OpenSSL function x509 to generate an x509 certificate. -rec indicates that the input is a certificate signing request. -ca create serial has OpenSSL automatically create a serial number for the certificate if it doesn't already exist. It keeps a track of these serial numbers in a .srl file, which ensures that each certificate is issued a unique serial number. We will set the expiration date of the certificate at 100 years in the future. Once again, for actual servers, you can expect this to be 6 months to a year, especially if you're getting it from something like Let's Encrypt. That means if you're running something like a home server, you should set up automated tools to get a new certificate every, say, year from Let's Encrypt or an actual CA. That's the better way to do this, but self-signing is a great way to test that all of this is working before getting actual certificates from a real certificate authority. Then we will specify the certificate signing request, our .csr file. We will give it the location of the certificate authority certificate and the certificate authority key. Those are the files we generated earlier in the CA certificates directory. Finally, we will tell it where to store our server.crt, which is our server certificate. You should see this certificate request self-signature OK, which means we have successfully self-signed our own server certificate. If you look at the permissions of this, you will see that root is the owner for your certificate, CSR, and key files. Or if you're running Ubuntu or, say, Raspberry Pi as your actual operating system and you're not doing this through a Docker container, this might be the user you use to call OpenSSL, which means we should change the permissions of these files and ownership because Mosquitto needs access to them. Let's go up a directory. We will change the ownership with the chown or ch ownership tool, -r for recursive, so anything in this certs directory, and we will change ownership to Mosquitto user and Mosquitto group. Let's make sure that Mosquitto can read, write, and execute in the certs directory. We will give the Mosquitto user the ability to read and write the server.key we just created, but nobody else should be able to even read that key because it should be private. We will give Mosquitto read and write abilities to server.crt, and we also want to give others the ability to read that certificate file because that should be publicly shared. For example, when a client connects over TLS to the server, it needs the ability to read that file, and those permissions should be such that the client can verify that the server is legitimate, use that public key in order to set up secure communications with the server and broker. If we look inside the certs directory, you can see that we have set up those files so that Mosquitto has ownership of them, and the read and write permissions are set up appropriately such that the key is a private key and can't be read by anyone else, but everyone else can read the certificate, I guess in this case, as well as the certificate signing request. In that Mosquitto directory, we also have our mosquitto.conf. Let's modify this because we want to set up MQTTS for secure connections over SSL and TLS. Scroll down to the bottom of that file and let's make a few additions. Here is where you can specify multiple listeners and open up additional ports. The first one, which is enabled by default, let's specify our listener 1883, which is the port, and 0.0.0.0 tells Mosquitto to listen on all available network interfaces. You could specify a particular interface here, but listening on everything is fine for our test setup right now. You can also specify options under this, but this is a basic unsecure MQTT connection, which means it can easily be sniffed, which includes things like your username and password. You could also not include this line and force users to connect over MQTTS, which we're going to specify next. Here we will specify the listener on port 8883 on that same 0.0.0.0 interface, which is all of the available network interfaces. We need to give it the CA file, the certificate authority file, which is at etc mosquitto CA certificates ca.cert. That's the one we generated to be our CA certificate. The server certificate file, which is at etc mosquitto certs server.cert. And the key file, which is the server's private key, That's at etc mosquito certs server.key. By doing this, we're telling Mosquitto that we want secure connections with SSL or TLS on this port 8883. Let's save this. Control X and Y. Enter to save. Then we will call mosquitto-c etc mosquitto.conf, which is the location of the configuration file we just edited, and -d to run it in daemon mode. This is a good chance to check the end of that mosquitto.log to see if there are any issues firing up Mosquitto. If you have something incorrect in the configuration file, they will be printed here. But it looks like everything configured correctly, and Mosquitto is indeed running and listening on the ports we specified. We are going to call this Mosquitto pub tool. We'll give it the location where we want to connect. In this case, it's just localhost. We will give it the port 8883 for our secure connection, and we need to pass in our certificate authority certificate. In this case, it's the ca.cert that we generated. This is like creating a temporary trust store. For example, like your browser might have a trust store with these ca.certs, and it will use that to verify the chain of trust when it receives the server.cert from the Mosquitto broker. We will give it the topic of kitchen/sensor as we did before, and give it the message of this JSON string temp equals 25. Notice the backslash quotation marks here are escaping out of the quotes so we don't early end that string. We will give it the username of IoT and the password of Mosquitto. The username and password are still needed here, but luckily they are encrypted now because we are establishing a connection with TLS and then communicating over an encrypted channel. Run that. You might not see anything happen here. Feel free to print out the log. And sure enough, we see a new client connected and immediately disconnected. To see those messages, let's subscribe to the kitchen topic. So we will call Mosquitto sub, give it the local host as our host name, -p for the port 8883. We will also need to pass in this CA file, give it the location of the certificate authority certificate, tell it which topic we want to subscribe to, in this case, kitchen/plus. That's that wildcard that lets us subscribe to any single subtopic under kitchen, -u for the username, IoT, -P for the password, Mosquitto, ampersand to say run in the background. Let's press up a few times to get to Mosquitto pub. This is our publish message. Let's run that. If you set everything up correctly, you should see the subscriber tool printing out to the console the message that we just sent from the publish tool. In this case, temp is 25. MQTTX is a great tool for testing MQTT. It is an open source graphical client which we'll use to test our broker. Download the installer for your particular host operating system and follow the instructions to install it. In your terminal, inside the container, feel free to check to make sure that your server, your Mosquitto server, is still running, and we can still have our subscription service going. So we will leave those running for now as background processes. I'm going to open up a new terminal. I am in my host machine right now, outside of the container. Navigate to somewhere on your computer. I'm going to go to the downloads folder. Call Docker PS to see the different Docker containers that are running. Here is the only container for me, and that is the Debian one we are running our Mosquitto broker on right now. I will need this container ID. So I am going to copy that. I'm going to call Docker CP so that we can copy a file out of a running container. I will give it the container ID number, and I will tell it where to find this file we're trying to download in that container. In this case, it's located at etc mosquitto ca certificates ca.cert. Just like we saw with the publish and subscribe tools, we need to get this certificate authority certificate so that our host-based client can verify the chain of trust when it gets the server certificate from the broker. And I'm just going to store this in my downloads directory as ca.cert. You should see that it successfully copied some kilobytes to the location of the file. Now bring up MQTTX. This is on my host machine, and I'm going to connect it to the server. When we ran our Docker container, we told it to forward the ports 1883 and 8883 so that we can make MQTT connections. I'm going to show you how to do this with an MQTTS connection. In here, in connections, press the plus sign and click New Connection. We will give it the name of a connection. This can be something arbitrary like My Mosquitto. We will tell it which protocol we want to use. In this case, we want to use MQTTS. You're also welcome to try this with basic MQTT and give it the port number of 1883, and you don't have to set up SSL or TLS. Notice that MQTTX also works with WebSockets. You can establish a WebSocket with your server, assuming you have set that up on your server, which we did not in this case, connect using WebSockets, and still publish and subscribe like you would MQTT. But for now, we're focusing on MQTT, and let's do this with a secure connection. So we'll choose MQTTS. Instead of this default host name, we're going to give it localhost. Remember, this name must match the common name on the server certificate. So if you're putting in the IP address of your server that's on your local network, so make sure that the common name on the server certificate or something on the server's subject alternative name list that should also be on the certificate matches the host name given here. Otherwise, you will fail the connection. The port should be 8883 for secure connections. You're welcome to change the client ID, but I'm going to leave it at this MQTTX and random string. The username should be IoT and the password should be Mosquitto. Those are parameters we set up in the Mosquitto server. Make sure that SSL and TLS is enabled and that SSL secure is enabled. We don't need to worry about many of these options, but we do need to tell it that we have a self-signed certificate. If you are using an actual CA signed certificate from something like Let's Encrypt, you can leave this option selected and it will use the CA certificate from MQTTX's or your operating system's trust store. But since we self-signed and generated our own ca.cert, we need to click this button and we need to give it the location of that CA file so that it can verify that whole chain of trust. So let's open the file. Let's pick our ca.cert, click open. You don't need to fill out the client certificate and client key unless you have set up Mutual Transport Layer Security or MTLS. But since we have not done that, we just need to provide the certificate authority certificate. Once you're done filling those out, click connect. With any luck, you should see connected, which means that we have successfully established an MQTTS secure connection to our Mosquitto broker that's running in a container. Now, let's go to Kitchen My Sensor. This is the name of the topic. We're going to publish something here. You can specify the type of payload here. I'm going to leave it at JSON. That seems to be very common in MQTT messages. We can set the quality of service. Sure, let's guarantee delivery of at least once. You could set this to be the retained message or not. We won't, since this is basic telemetry data, and you can fill out any other metadata here if you so desire. Let's send this message, and you can see that message was sent here. If we bring up our server, if we go to this container, you can see that it printed to the console the message that we received. Let's set up a subscription. Click the New Subscription button. You can do plus for one of your wildcards for any single subtopic, or you can do the hash or pound symbol for any topic or topics in Kitchen. So this is recursive. Any subtopics under Kitchen will be reported in this subscription. Let's leave quality of service at 0, at most once, since we're just reporting these. Feel free to change this, and we will leave the rest of this at default. So confirm that. Now let's say the Kitchen gets much colder. I'm going to send this message out again. And here you can see the subscription relaying that message to us. You can see how that went out here. And if we go to our server, you can see it received another message here. Feel free to keep playing with this to get an idea of how that publish and subscribe system works within MQTT. I hope this helps you get started using Mosquitto. Whether you are just testing MQTT communications or wanting to build your own full-featured IoT platform, Mosquitto is a great, simple broker. It's also a good way to test your knowledge of how TLS works so you can set up more secure servers.